In this video, I want to talk about scopes and closures in JavaScript. And I've seen a lot of people learn closures, including myself. And you sort of learn it the first time, the second time, the third time, and you sort of get it, but it doesn't really stick, and it never really makes intuitive sense. So in this video, I want to try to give you an intuitive understanding of how closures work to the point where it sticks and you really understand what they are. Okay, so I want to start off by talking about actually the C programming language, because I think this background is going to be helpful. So this is some C code right here, and I have a function called inner, which just declares a variable named C, a function named middle, which declares a variable named b and calls the inner function, and a function named main, which declares a variable named a and calls the middle function. And one thing to note about C is that sort of by default or implicitly, the main function is just ran. So if I run this program, main implicitly gets run. So let's go through a trace of this. And something to know is a concept called the call stack. So when a function is run, that function gets added to what's called the call stack. So when main gets run, main gets added to the call stack. And its variables that are local to main are part of this. So, whoops. A is here, and inner is in scope, so inner is here, and middle is in scope, so middle is in here. Okay, so main gets run, and its variables get added here. Then main calls middle, so middle is added to the call stack, actually. Okay, and middle introduces the variable b. Okay, and then it calls inner. And inner gets added to the call stack. And inner has the variable c. Then what happens is inner finishes. And, it doesn't do anything after declaring the variable c. So it returns. And when a function returns, that function gets popped off the call stack. Then middle also returns. It doesn't do anything else. So it gets also popped off the call stack. And then the same thing happens for the main function. It finishes and it gets popped off the call stack. And the reason why I bring this up is because you would think that, that after a function gets popped off the call stack, its local variables would just be gone and you'd never be able to access them again. So when inner gets popped off the call stack, you'd think that C is just gone forever and you can never access it. But that's actually not the case in JavaScript. In JavaScript, there are these things called closures, which allow you to access variables that are local to a function even after that function returns. So that's pretty cool. You can't really, do that in every programming language. Okay, so let's move on to a JavaScript example and do something similar. So yeah, this is like the typical example that demonstrates closures, where you've got an outer function that has a variable, and it returns an inner function, which tries to access that variable. So let's go through a trace of this, similar to what we did before, using call stacks. So the outer function is declared, and then it is called. So when it's called, it gets added to the call stack. And what is in scope right now in here is visible. Visible is part of outer. and inner. Okay. Then outer returns. It returns this inner function. And when outer returns, it gets popped off the call stack. And inner is then called. So it would get added to the call stack. And it doesn't declare any variables, so nothing gets added in here. And it's trying to access this visible variable. But wasn't that popped off the call stack before? Yeah, I would think that since it was popped off the call stack, it's no longer accessible, and this would be undefined because it's trying to access something that doesn't exist. And in fact, that's not the case. The variable is named visible, so I'm sure you were able to infer that it is actually visible. And that's the case. When you console log this visible variable, the string visible is going to be returned and logged out. And why is this? The reason for this is because of closures. And let me get this. So the deal with closures is that when you declare a function, that function will always have access to whatever was in scope when the function was declared, even after the scope was quote-unquote destroyed. So when we declare this inner function, what's in scope? Let's do this. Let's make a little box and say, what is in scope when this function is declared? What is in scope when inner is declared? Well, outer is in scope, and visible is in scope. So when we declare this function, these two things are in scope. So that means that inner will always have access to these two things. Even when outer returns and is quote-unquote pops off the call stack, inner will still, no matter what, always have access to these things because these things were in scope when inner was declared. And that's the rule you have to understand about closures. Ask yourself this question. If it helps, draw it out and make this box, and that'll tell you what your function will have access to. So yeah, you can, I don't know, sort of maybe operate with this understanding, like you might be able to accomplish your tasks, use closures in your code, but let's move a little further and try to understand a little bit about the inner workings of closures, because I think that'll help you to have a deeper understanding. So before we get into the inner workings, let's just talk about scopes in JavaScript. And I think it'll be helpful to think of scopes as JavaScript objects. Yeah, so let's look at this. Oh, and just a little reminder, this video isn't about scopes, but JavaScript has function scope, so functions are the only thing that creates scopes in JavaScript. If we had an if statement like this, this wouldn't create a new scope. In other languages, a lot of other languages have what's called block scope, where any block like this would create a new scope. And that's not true in JavaScript. In JavaScript, only functions create scopes. So with that said, let's go over what the scopes in play here are. So we've got this global scope, and we'll think of it as a JavaScript object. And A is in this scope, and outer is in this scope. Okay, then this outer function creates a new scope. So we've got this outer scope, and B is present in this scope, and the function inner is also present in this scope. Okay, now so yeah, inner also is a function, and functions create new scopes. So the inner scope has C, Okay, so I just wanted to get you thinking about scopes as JavaScript objects. So now let's talk about closures. If you remember, our thing with closure is that when you declare a function, that function will always have access to whatever was in scope when the function was declared. So the way that this works is when a function is declared, a closure is created. So let's look at outer. When outer is declared, it creates a closure, and the closure is like a scope object. So when outer is declared, A is in scope. So this outer closure will have A, whatever was in scope when outer was declared. And similarly, inner, when it's declared, it creates a closure. And what is in scope when inner is declared? Well, A is in scope. Outer is in scope. B is in scope. That's pretty important. And yeah, so when inner is declared, it creates this closure here. And let's go over why that's important. So let's augment this example a little bit to see. Let's do this. Let's try to console log B. And let's do this. And this. Okay, so let's go through a trace here. First thing is A is declared and is initialized and assigned, whatever, outer, blah, blah, blah. So let's start off with the call to outer. The call to outer creates this scope, creates this closure, and the call to outer returns this inner function. And so inner is equal to this inner function. And when we call inner, inner always has access to its closure. So inner tries to console log B, and it's capable of doing that because even though outer returned and this outer scope is effectively gone, this is effectively gone, inner has access to its closure, and its closure has B. So that's why the string B is going to be logged out instead of undefined, because inner has access to its closure, and its closure has B, even though outer returned and the outer scope object is gone. And that's basically how closures work, is these closures are created at the time the function is declared, and the closure is accessible to the function all the time. And so that's how closures work under the hood. We could get a little bit actually deeper under the hood, and we'll see if this is helpful. So what I just told you isn't really quite true. The way it really works is when outer is declared, part of outer's scope is this sort of scope property thing, and it references the scope, the parent scope, if you will, so global. And when inner is declared, it's also got this scope property, or I'm sorry, a closure property that references outer. So when outer, let's go through the trace again. So outer, what's it called? It runs, and you'd think that this would be popped off the call stack, right? But the call stack really, in JavaScript, it uses the heap, so actually forget about that for now. Anyway, you'd think that this would be gone, but outer returns inner, and inner references this. Inner is pointing to this. And because there's something pointing to this, basically it's never going to get garbage collected, if there wasn't something pointing to this, if this arrow was gone, this would be garbage collected whenever there was an opportunity to do that. But because there's something pointing to it, it's always going to be in existence. And so when inner tries to console log B, this is going to exist, and B is going to exist, and it's going to log out B. So that's about as far under the hood as, well, you can get further under the hood, but that's pretty deep. And if you understand this, you should have a pretty good understanding of closures. I'm not going to talk about why to use closures here. This video is getting pretty long, and I feel like that's sort of a different topic. But hopefully this gave you an understanding of how closures work. And in the description, I'm going to link to some other good resources that I borrowed pretty heavily from. And yeah, those are good things to read up on to give you an even better understanding of closures. So I hope this was helpful.